Alright, so this is my personal interest topic project, and I did my project on the physics of black holes, as you can see there. Alright, so first of all, I'm gonna go over my objectives. Sorry. So my four objectives are, first of all, teach what a black hole is. Most people don't really know what it is. They've heard of it, but most people need to understand it. Two, teach where black holes come from, how they're created in our universe. Three, teach the math involved in understanding black holes, which, a little disclaimer here, I'll be going over like the very introductory level math involved with the black holes because the really upper level things is well beyond my level. And fourthly, teach why black holes are so difficult to study, as they are one of the more complicated topics in modern physics, and there's a lot of studies in them through astronomers and all that stuff. So we'll learn about why they're very difficult. Alright, so first of all, what is a black hole? So NASA defines it as a place in space where gravity pulls so much that even light cannot get out. This is because all the matter in a black hole has been condensed into an infinitely small point. And because they cannot contain light, they are invisible, hence the description black. So you can't see them with the naked eye or anything. They're just blend into space because there's no light. Alright, so there are two kinds of black holes that exist in our universe that we know of. Now, another disclaimer, the recent discovery has some people saying there may be an intermediate kind, but traditionally black holes have been put in two categories. The first of which is stellar mass black holes. Now these are not small, they're like 10 to 24 times as massive as our sun, but in comparison they're smaller than the other kind. So, and then they're also very abundant in our universe. 10 million to a billion exist in just the Milky Way alone, based on recent estimates. So these are very common, they're everywhere, and they're still much larger than the sun, but not as big as the next type of black hole, which is a supermassive black hole. These are millions, if not billions, times more massive than our sun. And they only exist in the center of each galaxy. So there's only one in the Milky Way that we know of. Again, recent studies, may combat this, but traditionally there's only one in the Milky Way, and it's always at the center, and there's one in each large galaxy. Alright, so you may be asking, where do these black holes come from? So, first of all, I need to say that we do know where stellar mass black holes come from, but we do not know where the supermassive black holes come from. Those, we have never seen one be created before. They exist in the center of each galaxy, like I said earlier. So scientists are still trying to discover how they came, where they're from. But for stellar mass black holes, we know one way that they can be created is when a star runs out of nuclear fuel, causing them to collapse under their own gravity. It may also come from two stars colliding, which will cause the gravity of the two stars to pull each other apart and a black hole to be formed. Alright, a very important part of black holes is the event horizon. So, if you've ever seen a picture of a black hole, you've probably seen some spherical picture, which is really what they're portraying here is what's called the event horizon, which is the outer surface of a black hole. Here, the gravitational pull is so strong that not even light can escape. So, therefore, we don't know what's beyond the event horizon because light can't escape it, so therefore we can't see behind the event horizon. This is due to the extremely large mass compact into a single point. That is why the gravitational pull is so strong. And like I said earlier, because the pull is so strong, light can't escape, sound can't escape, nothing that we put into a black hole will ever come back out, so we don't know what's behind the event horizon. Alright, so now I'm going to discuss the math involved in black holes. So, like I said earlier, this is going to be a very elementary overview of the math involved, but still important to get the basics down. Alright, so The math in black holes are heavily dependent on Einstein's theory of general relativity, which states that what we perceive as the force of gravity arises from the curvature of space and time. And the equation that is portrayed or derived from this theory is the famous equation E equals mc squared, which I have written here. E here represents energy, mass is obviously mass in kilograms, and c is the speed of light, also 2.99 times 10 to the 8th meters per second. Alright, so I have a couple practice problems over here that pertain to this equation. So, first of all, if a black hole has the mass of 2.98 times 10 to the 31 kilograms, how much energy will it produce? So all we have to do here is, we're looking for E. Oh, this one's not that good. Let me grab another marker. Yeah. E equals M. The mass here is 2.98 times 10 to the 31. And then C, which is 2.99 times 10 to the 8th meters per second, and that's squared. And to enter that in your calculator, you will get 2.66 times 10 to the 48th joules. So 2.66 times 10 to the 48th joules. So it's fairly straightforward. All you're really doing is plugging in different equations, but you have to make sure your units are right. Meters per second, kilograms, all that stuff. And make sure you put the answer in joules, which is the unit for energy. Alright, number 2. Practice problem number 2. If a black hole has 3.07 times 10 to the 41 joules of energy, what is its mass? So here you're going to do a little bit of maneuvering around, algebraic maneuvering. So if E equals mc squared, and you're looking for mass, mass is going to equal E over c squared. Right here. And then you know E here is 3.07 times 10 to the 41. And C, again, is 2.99 times 10 to the 8th. And this is going to be squared. And put that in your calculator. You will get 3.43 times 10 to the 24th kilograms. Alright. Again, fairly straightforward, nothing too complex here. So, yep, that is the math involving the black hole. And just to review, some of the key terms that you'll need to know for the assessment are the basic definition of a black hole, the two kinds of black holes and what they are, the two ways black holes can be formed, what an event horizon is, why the gravitational pull is so strong on an event horizon, and you'll need to know nothing too specific, but generally you'll need to know Einstein's theory of general relativity and how to use the equation. Fairly straightforward. Alright, now lastly, I just have my sources here on the bottom left. The sources I use are nasa.gov, very reliable government agency, cfa.harvard.edu, great educational platform, or not platform, institute, and space.com, which is a very good extraterrestrial organization. Alright, that is the end of the video. There will be a review assignment and then a assessment on this information that will be needed to be completed. Alright, thanks you for watching.